So here we have another question to answer. A solid metal cube of size 12 centimeter is heated from 20 degrees centigrade to 70 degrees centigrade. So if the linear expansivity of the metal is 1.2 times 10 to the power of minus 5 per Kelvin, determine the increase in volume. And we have the following option. A, we have 2.6 centimeter cube, we have 3.0 centimeter cube, we have 1.0 centimeter cube, and we have 4.80 centimeter cube. So ladies and gentlemen, in the present video, I want you to understand something, that we have what we call expansivity of a material, and this expansivity of the material is actually divided into, we have three of them. We have what we call linear expansivity, linear expansivity. What is linear expansivity? A linear expansivity is the increase in volume for unit volume for degree rise in temperature. So therefore, a linear expansivity is when you have a material and due to increase in temperature, you had an increase in the length of the material. That is what you call linear expansivity. Let's say you have an original material like this, and the length of the original material, let's say, is like this, and this is the initial length, that is L1. And then when this material, maybe due to increase in temperature, it increases in length, like this. So we have L2. So a linear expansivity is when you have an increase in length for unit length for degree rise in temperature, is what you call linear expansivity. That is when you have an increase in length of material due to increase in temperature. So that is why you see this is your original length and this is the final length after you increase the temperature of the material. So therefore, to get the increase in length of that material, so it's going to be extension. Let's use E as an extension, that is increase in the length. So we have L2 all over L1. Let's say the L1 originally, let's say you have 2 meter here, and then the L2 here, let's say you have 2.5 meter. So if you want to calculate the increase in length in the material, so you can now see increase in length, that is L2 minus L1, is now going to give us 2.5 minus 2, which is going to be 0.5 meter. So that means this is an increase in the length. So apart from the linear expansivity, and we have the formula, the general formula for the linear expansivity, which is represented with alpha. So alpha represents linear expansivity. So the formula for calculating linear expansivity, alpha is equal to L2 minus L1 all over L1 with also increase in temperature. That is theta 2 minus theta 1. So theta 2 is the final temperature and theta 1 is the initial temperature. Because let's say here when we have an L1, let's say the initial temperature here, let's say theta 1 at this point, let's say is 15 degrees centigrade. And maybe due to this increase to about 0.5, so when the temperature increases, let's say from theta 1 to theta 2, and let's say the theta 2 here is 25 degrees. So you see, due to increase in temperature from 15 to 25 degrees centigrade, it leads to an increase in length. So when we say linear expansivity, it means it's an increase in length for unit length for each degree rise in temperature, meaning that when there is an increase in temperature, then there is a likelihood that there is going to be an increase in length due to the increase in the temperature. So then apart from the linear expansivity, we also have area. We also have area expansivity. Area expansivity. So in the case of area expansivity, it is represented by beta. So the formula for calculating beta, because in this case, it is actually due to increase in area. It's due to increase in area for unit area for each degree rise in temperature. So here is not longer a length, rather it is volume. So therefore, in the case of area expansivity, we are dealing with area. So beta is equal to area 2 minus area 1 all over area 1 divided by area 1 theta 2 minus theta 1. and of course this area expansivity is 2 times alpha. And then the next one is the volume expansivity. Volume expansivity. So in the case of volume expansivity, ladies and gentlemen, we have V. So it is represented with gamma, and then this gamma is equal to, because it is associated with volume, that is increase in volume for unit volume for degree rise in temperature, and you have V1 into theta 2 minus theta 1. So this is actually volume expansivity, and of course from this volume expansivity, or you can call it cubic expansivity. So cubic expansivity is 3 times alpha. So these are actually very important in thermal expansion, where we have linear expansivity, area expansivity, and volume expansivity. And I think, ladies and gentlemen, from here you can see that these questions is actually associated with one of these, because we are talking about the cube. So cube, it means we are associated with the volume. So that's why here we want to determine an increase in volume. So therefore, this is the formula that we are going to use at this point. So without wasting our time, I'm going to bring the data. So how are we going to bring the data? I'm now going to say solution, then data. I'm going to bring the data. So we have the length here. It is given as length is 12 centimeter. But remember, volume is cubic. So volume is equal to L power 3. So therefore, that is length cube, length power 3. So therefore, we are going to have 12 centimeter raised to the power of 3. So 12 centimeter raised to the power of 3 will give us 1728 centimeter cube. This is actually, this is our V1. So let me clean this. So you see, we have this, and we have alpha, which is linear expansivity. It is given us, as we can see here, is 1.2 times 10 raised to the power of minus 5 Kelvin. But remember, what we want to get is the volume, is the increase in volume. So therefore, in this case, the linear expansivity must be converted into the cubic expansivity, that is the volume expansivity. And remember, cubic, which is gamma, is equal to 3 times alpha. So therefore, gamma now is equal to 3 times 1.2 times 10 raised to the power of minus 5. So when you multiply this times 3, we have 3.6 times 10 raised to the power of minus 5 for Kelvin. So we have this, and then the next one is we have theta 1 is equal to 20 degrees centigrade, and we have theta 2 is equal to 70 degrees centigrade. So now what we are going to do, I'm going to clean this space here so that now we have this. So the next thing now, we have everything here. So the next thing, we have to take our formula. Gamma is equal to V2 minus V1 all over V1 upon bracket theta 2 minus theta 1. So we have our gamma here as 3.6 times 10 raised to the power of minus 5. And then we have equals to the V2 is unknown, so we have V2 as unknown. And of course, what we want is the increase. So we want to get the increase in this. So V2 minus V1 is what we are going to get. And divided by the V1 is equal to 1728 centimeter cube. And then we have the temperature 70 minus 20. So 70 minus 20 will give us 50. So we can now make this subject of the formula. So we have V1. So the V2 minus V1 is equal to 3.6 times 10 raised to the power of minus 5 times 1728 times 50. So therefore, if we now take our calculator, what are we going to get here? We are now going to get 3 points. We are going to get 3.1104 centimeter cube. So this is the increase in length. So which one actually look like our answer? It is going to be option B. Because when you approximate this, it is going to give us this option B. So ladies and gentlemen, I hope you enjoy this video. Please don't forget to subscribe and join the YouTube community for more. So thank you very much. So follow for more videos.